And we're live. All right, cool. Thank you everybody for joining me today. Today I will be talking about passwords, and not necessarily in a good way, because passwords have been around since a very long time. And there might be some things about passwords that annoy me. So a little disclaimer, if you like passwords, if you're very passionate about passwords, you might want to switch to track 1 of this conference instead of sticking around. But if you do stick around, I hope you will enjoy this talk and maybe learn a thing or two about passwords and see what the future might hold. So we might be able to get rid of passwords anyway. But before I start, let me quickly introduce myself. My name is Bellen. I'm a developer advocate engineer at Auth0. And if you've never heard of Auth0, that's fine. We're an identity as a service provider, which means we try to make it as easy as possible for anybody to implement a secure authentication flow, so you can focus on actually building your actual products. I'm also a Google developer expert, and I organize a few meetups, Frontiers in Belgium and Identity and Security meetup in London. Should you ever be in Europe and in one of these countries, please join us, because we're nice people. And you can find me on the internet as @SamBagel. Almost all of the websites have @SamBagel as a username. Okay. I'm a front-end engineer, or I come from a front-end engineering background, so it only makes sense to me that I'm also npm installable. So if you run npx @SamBagel/about me and download half of the internet, you can find all the necessary links you need to contact me or to find my slides as well. So in this talk, we're going to see a few things. We'll start with a little bit of history on passwords, see where they come from, how long they've been used, things like that. Then we'll transition to different types of passwords, because there's more than just one type. In our daily lives, we encounter different types of passwords. We'll see what they are. We see their pros, we see their cons, their weaknesses and strengths. We'll learn all about that. Then we go to passwordless authentication, because since a while now, we've started to realize that passwords are not the user-friendliest way, and they have some downsides. So we see some current solutions for passwordless authentication. And last but not least, we go to the Web Authentication API, which is a newer standard on the web, which allows authentication on the web without passwords, but with a public and private key. So that's all at the end of this talk, which is the coolest part, in my opinion. So let's get started. A bit of history on passwords. Like I mentioned, passwords have been around since a very, very long time, even before Christ, when there was this little group of people called the Romans, which were ruling most of the European and the areas around the Mediterranean Sea. The Romans used passwords. This has been documented by scientists, and they used passwords in case they encountered a group of people that they didn't know. So if one legion of Romans encountered another legion of Romans, they might have asked for a password. And if they both got the password right, they might go for a bit of wine or a beer. And if they got it wrong, well, they might fight till the death. A bit later, somewhere around the 10th century after Christ, a new story was written, and the story is the story of 1001 Nights, and this talks about a lot of things in the Arabian world. And one of the stories inside of the story is the story of Ali Baba and the 40 Thieves. And you might be familiar with it. But basically the story goes, there's 40 thieves who are stealing all the gold and jewels in all of the region, and they hide it in a cave. And in order for somebody to open that cave where they hide all the gold, you have to say the magic phrase, "Open Sesame." And "Open Sesame" basically is a password. It's a password to open the cave in this story. Well, if we fast forward a bit to more recent times, into 1961 to be exact, the first time-sharing system was introduced at MIT. And the brilliant scientist Fernando Corbato invented this. And a time-sharing system, if you're not familiar with this, back in the day, not everybody had a cell phone in their pocket, not everybody had a laptop or a desktop in their office. They had one computer, one mainframe in the whole university, but they wanted to give access to as many scientists as possible. So everybody got 4 hours back in the day, 4 hours of computing time. And they all used the same mainframe, which had the same CPU, the same hard drive. So they used a password to basically protect each scientist's piece of work. So they could only access their own work and not the work of other scientists on that one big computer, the time-sharing system. Then let's forward at least 9 years. Robert Morris Sr. invented hashing, which means that at least the first 9 years, passwords were stored in plain text. And if you're a bit familiar with security best practices these days, we do not store passwords in plain text. So if that's something you take away from this presentation, that's already a good thing to remember. Please don't store your passwords in plain text in your databases or wherever you store passwords. But do that in a more secure way, like using hashing, for example. And then in the 1990s, hacking became more of an issue just because the web exploded. Everybody wanted to be on the web, wanted to be the next startup to make it big on the web. So when there's a lot of companies on the web which deal with a lot of data, there's also people trying to misuse that data and trying to steal the data, and hacking became more of an issue. So people tried to get access to the databases of all these companies new to the web. So we've seen a bit of passwords. They come from all the way before Christ, from the Romans, and probably even before that. And they were first introduced in computer science around 1961, and we've been familiar with them ever since. So let's look at a few different types of passwords. The first one, first we have to ask ourselves, what is a password? And to me, a password is anything that's a shared secret. So it doesn't matter which form it has, as long as it's a shared secret that me and another party know, then it's a password to me. By the way, if you have any questions, feel free to ask them in the YouTube chat, and I will try to have a look once in a while to see if there are new questions. So the first type of password, it's the one we're most familiar with. It's a string. Anytime we want to log in on a website, or most of the times, we enter a username and a password, and that password is a string. Of course, your password is not going to be password1234. I hope if this is your password, I might urge you to change that password, as it's not a real good one. My first password when I was very young and we got our first computer with internet at home was ColdDog. I don't know why I chose this, but I thought it was funny back in the day. I was young, like I said. I don't use this anymore, so don't try to hack my Gmail or any other accounts, because this does not work anymore. But usually a password is a bit longer. It's some random characters. It has some digits, maybe a symbol in it. It looks a bit like this. And the downside of these complex types of passwords is they can be hard to remember if they are complex. But if you use a complex password, you can also use a password manager, and they can help you remember them. They can even generate them for you, so you don't have to do that yourself. But because they're hard to remember, it also means that they can be hard to guess by other third parties, people who want to try to guess your password, who want to try to force their way into your accounts because of their complexity. The next type of password is a PIN code, and a PIN code is just a few numbers. This can be 3, 4, 5, 6. It doesn't matter. Usually it's around the 4-ish type number, so 4 digits. And we use this a lot. We use this with our ATM, at ATM with our banking cards. We use this for SIM cards for our phone, maybe to unlock your phone even. Sometimes when you enter a building, you might have to enter a few digits on a keypad next to the door as well. These are all PIN codes. And a PIN code is just a password in the form of digits instead of a string. And the downside is they're not so hard to guess because, well, the math is easy. If you have 4 digits of a PIN code, there's not too many combinations. So it's a limited set of combinations, so not hard to guess. But they're often combined with a maximum allowed number of guesses. For example, I can only try 3 times with my banking card or with my SIM card. And after those 3 times, if you've had 3 times that you fail to get the right PIN code, you're done. You cannot go any further anymore. But they're fairly easy to remember for anybody who needs to actually use that PIN code. So I remember a few PIN codes myself, one for my SIM card, one for my phone, one for my banking card. They're all different, but they're easy to remember because they're all a few digits. So it's fairly convenient. And they're usually used with something physical, in combination with something physical, the actual banking card, the actual SIM card in your phone or your actual phone, the keypad next to the door. So even if somebody would be able to guess your PIN code, they also need access to that physical thing. So the combination of that physical thing and the PIN code makes them a bit more secure anyway. All right. There's one question in the YouTube chat. Is that Robert Morris, the father of the notorious Robert Morris, responsible for the Morris Worm in 1988? And I'm sorry to admit, but I do not know the answer to that. But that might be something that we can Google later. Good question. Thank you. All right, so the next type of password is a pattern, and we see this on Android phones a lot. And usually when I do this presentation live in an audience, I ask who has this on their phone, and you see quite a few hands go up because it's very, very convenient to use a pattern like this. If you've done it a few times, it just goes into your muscle memory, and you just unlock your phone by swiping the pattern without even realizing you did it, because it just feels so natural. But this pattern, of course, is also a type of password. And in the background, this might be translated to a PIN code, might be translated to something else, but it's a type of password anyway. The downside of this, touchscreen often revealed the pattern as a dirty spot because, well, we don't clean our screen after every time we enter this pattern, we enter this password. Nobody does this. If you do this, you're very nice and keep on doing this, but I think most of us are too lazy to do that anyway. So these touchscreens often reveal those patterns. And people often use their initial letter. Like for me, the S would be my initial letter, or the lucky number. Maybe that's 1, maybe that's 4. So it might be easier to socially engineer or to guess the pattern if you use one of those things related to your identity. And people often do this because they have a connection with their initial, for example. But if you use a pattern, it's very easy to remember. Like I said, it goes into your muscle memory. So you can do it automatically after a few times. So it's very convenient. So we've seen a few types of passwords: a string, a PIN code, a pattern. There are a few others out there, but basically anything that's a shared secret, like I said in the beginning, is fine for that. So what's the problem with passwords? Well, let me illustrate this for you. And on the slides, we have a regular login form like we see on most websites these days. You have a username, you have a password. And when you log in, of course, the first time you fail because nobody is able to type their password correct from the first time. That's normal, right? So you retype your password and you do a second guess. And again, doesn't work. What's wrong? Maybe I drank a bit too much beer. I'm drunk. I'm a bit sleepy. Doesn't matter. But of course, the third time is the charm. So the third time it will work. Still failed. So what do? You're going to reset your password. So you try to reset your password. And when you do so, you get this message. This is something that I've had happen a few times. And again, when I ask this to a live audience, I see a lot of people who are familiar with this. Your password is the same as you cannot reset your password because the one you entered is the same as your old password. So you thought you forgot your password, but in reality, you just mistyped it again because there might be a lot of reasons why you mistype your password. So passwords are very annoying. They're very inconvenient. They're not user-friendly at all. They make me angry at times. So passwords can be annoying. If you use a password manager, they can help you remember your passwords. They can help you with inputting your passwords, so it makes the typing part go away, but it's still a bunch of passwords, and it's still annoying because you need a third-party app to handle your passwords. It's not really the best thing in the world, even though I can recommend password managers. Passwords itself have a problem or a few problems. And one of the biggest ones is that user data can get stolen. Especially lately, we see a lot of hacks going on. We see a lot of public data, of private data being leaked or being accessed by people. If you look at some data from last year, in January 19, Marriott Hotels lost 383 million records. To be clear, all of these examples doesn't mean that they lost passwords. I think none of them actually lost plain text passwords, luckily. But it does illustrate that a lot of people are trying to hack bigger companies, bigger websites that handle a lot of data, and are trying to access all that private data. So if you can get rid of passwords, that's already one piece of private data that we don't have to worry about anymore. So if we go to April 2019, Facebook lost 540 million. August, MoviePass 160 million. September, Words with Friends, 218 million. And then in October last year, People Data Labs lost 1.2 billion records. That's a lot of data. And if these don't contain passwords, because we don't use passwords, that would already be a great thing, even though it's never a good thing when a company loses data or when somebody hacks a company and gets access to data without being allowed to access that data. If you use Auth0, we have a nice feature which is called the breach password detection, which basically means that if one of your users tries to log in with a combination of a username and password that has been known to be breached, we will notify that user. We will notify the admin of the website, and they can maybe ask the user to reset their password to create a new one. If you don't use Auth0, there's also a nice Chrome plugin for that does exactly the same thing. When you try to log in on a website with a combination of username and password that has been known to be breached, because there's databases of those, the plugin will notify you that, hey, maybe you should reset your password. So if you use this and you see this plugin tell you that your password has been breached, please reset your password. So a few tips for good passwords. The first one, use a complex password. And I must say that length is more important than the actual complexity. But the more complex, the longer, the better the password in general. Don't use any personal data. So don't use the first name of your mother, for example, because people might be able to socially engineer your password. They might be able to guess it because they know you, or they might start following you on Twitter or Facebook and get some personal data from you. So don't use any personal data in your passwords. Don't reuse passwords, which means that any website you register for, you create a new password. Don't reuse passwords across multiple websites, because if one website loses your password, those passwords might be used with credential stuffing attacks on other websites, which means that people might try to use that password on other websites as well. And if you reuse them, then they will be able to get it into your other accounts as well, which is never a good thing. And lastly, you should try to change your passwords frequently. Not a lot of people do this. Me, myself, I also don't actually do this. But if you change your password on a frequent basis, every 6 months, every year, it means that if they get leaked after a certain amount of time, they will be useless anyway. These are a few tips for good passwords. My friend Joel Lord on Twitter, he has a few very funny stickers. Passwords are like underwear. Don't leave them on your desk, or don't share them with strangers. Which is actually a very good, I like it. If you ever see him at a conference, go ask him for these stickers because they're nice. And remember that passwords are like underwear. They're private. So if you fast forward a bit, we go to passwordless, because like I mentioned in the introduction, we have started to realize, and we as people building applications and also people using applications, is we started to realize that passwords are not the best way, or not the easiest way to authenticate ourselves on the internet, on other computer apps, on mobile phone apps, in general. It's a very, there should be easier ways. And the first example of a passwordless approach would be one-time passwords. And I'm sure most of you will be familiar with them in a certain way or the other. But they're often valid for one-time use, which means once you use them, they're not valid anymore. They often expire after a certain time, maybe 30 seconds or 2 minutes, but they're only valid for a certain amount of time. And after that, they're also not usable anymore. And they're usually sent directly to the user, which means that you request a password whenever you need, and they're sent directly to you. This can be sent in an SMS. And if you use iOS or Android and you get an SMS with a one-time password, they both have a functionality that lets you easily input those one-time passwords with the press of a button. For example, here I get a one-time password for my second factor authentication on GitHub, and my keyboard just noticed that I got a text with the one-time password, so it just lets me tap that keyboard, which is very convenient. I don't have to type all the numbers myself. But the downside is that not all telecom operators take security serious, which means that in most cases, SMS messages can be intercepted. I'm not saying that they will be intercepted, but there's always a possibility, which means that somebody might be able to get to your one-time password before you do. And you need your cell phone on hand, because it happens to me quite a bit that my cell phone is in another room and I'm on my laptop and I try to log in, and I have my second factor authentication with a one-time password, which is sent to my phone. So I have to go and find my phone before I can actually log in, which is annoying, but it's just a downside of having a bit more security. The second way that these one-time passwords are sometimes sent is sent in an email. For example, if you're using Slack, I know that this conference also has a Slack channel, so maybe all of you are on Slack. You have the opportunity to get a magic link, and this link, when you click on it, it will log you in automatically. But basically, this link contains a one-time password, and that's sent directly to my email address. Which is nice, because you don't need a second device, because usually you have your email set up on the device you're trying to access a website on anyway, most of the time. But again, emails can be intercepted, so people might be able to get to your password before you do. It's a downside of using emails and SMSs. The chances are not that big, but there's always a possibility that that happens. The next way is an authenticator app. And I see this being used by a lot of people. Most people use the Google Authenticator app, which is a really good app. It works quite well. And what this does is it generates a one-time password for you. And this password is only valid for 30 seconds. You can add a bunch of websites to those apps. But it basically creates those one-time passwords instead of sending them to your email or to your cell phone. We also have one at Alt0, which is called Guardian. Does exactly the same thing. It generates a one-time password. And there's a bunch of others out there. Duo has one, LastPass has one, there's Authy from Twilio, Microsoft has one, and I'm sure there's a bunch of others out there as well. So you have a bunch of choice, and I do recommend these because they work with a shared secret, and based on this secret, the app can generate a one-time password, and there's no need to send this to your phone or to your email. And they're often time-based, which means that after 30 seconds, for example, they will generate a new password, which means that those one-time passwords are only valid for a very short period of time. The period of time usually needed to actually use this one-time password. For example, in the Google Authenticator app, your numbers become red and the pie chart on the right will get very small when your time runs out. And they can also be push-based. For example, this app can send you a push message on your phone. You just click on the push message and you're logged in. No need to worry about typing in the numbers yourself. Just click on the push message and you're magically logged in. But they rely on a shared secret between the app and the authentication service, which means that if the secret gets leaked, somebody might be able to create those one-time passwords and basically falsify those one-time passwords. So that's why it's called a secret. Those secrets should always be kept secret. Next up, social login. It's something like login with GitHub, login with Google, login with LinkedIn. We see a lot of websites offer this functionality these days. Also, mobile apps do it a lot. And it's just because we know that most users of our websites, of our mobile apps, already have a Gmail account or have a Microsoft account or have a GitHub account. So why not reuse those accounts and let them log in through them? It's very convenient. The user doesn't have to enter all their user data again, doesn't have to remember an extra password for you again. So it gets used quite a bit. I'm a big user of it myself. I use it whenever possible because I'm a lazy person. I like this. And like I said, it's one less password to remember. If I use login with Google everywhere, it just means that I have to remember my Google passwords and no other passwords for any of the other websites out there that I use login with Google with. It also means that I only give a password to a service I trust. If I log in with Google, I kind of trust Google to handle my data and to handle my passwords in a secure way, even though they also lost some passwords in plain text last year. But in general, I think they know what they're doing. So if I log in with Google or GitHub, it kind of means that I trust them to handle my passwords, and I don't have to give a password to a service that I maybe want to be trying out, but don't really trust yet because they're new or I've never heard of them before. But it also means that you rely on another service for authentication. So if the Google authentication system goes down, it means I'm locked out of a lot of services as well because they need to do the authentication part for me. You rely on another service. That's a downside. Some other authenticator apps are It's Me. That's something we have here in Belgium. It's linked to your ID card. You have Yoti, which does some very cool facial recognition stuff. So you can basically log in with your face. And it's quite advanced. It's super cool. I would say definitely check them out. And then there's VoiceIt, which does the same thing, but then based on your voice. So there's some voice recognition and lets you log in with your voice. And these kind of one-time passwords and these authenticator apps, we've seen them, we might have used them, but they're often used as a second factor because that's how we do it these days. We have a first factor, which is our password, our username password, and a second factor to be more secure. It's a one-time password, or it's generated or it's sent to you, doesn't matter. So they're often used as a second factor. But they don't have to be. They could also be a first factor in theory, but let's move on to the Web Authentication API because that's even cooler than this intermediate approach that we just saw with one-time passwords. The Web Authentication API is often called WebAuthn for short. So if you want to Google some more information about the Web Authentication API, Googling WebAuthn might give you some more information just because us developers were very lazy. So if we can type something shorter like WebAuthn, we will do this. But what this is it's basically a key-based authentication mechanism on the web. And what this means is that you have a private key and a public key, and they handle the whole authentication flow. There's no need to use a password anymore. You just use your private key and your public key information to do the authentication. And they use a hardware authenticator. And that hardware authenticator will store your private key. It will sign some challenges. It will do some things during that authentication process. But that's the only thing that authenticator will do. It will only concern itself with authentication. It's not it's something special. It's hardware, and it often looks like this. And you might have a YubiKey or a Google Titan key. There's a whole bunch of different of these authenticators out there. You have them in open source all the way to the right. You have them for USB-C, you use USB-A, you have them for Lightning, for your iPhone, you have them with Bluetooth, NFC, and you even have them with a screen like the Trezor on the left. So there's a whole bunch of them out there. These are all authenticator devices, which means that they know how to store private key information securely, and that they know how to use a private key to sign challenges. Like I said, you have them in USB, you have them in Bluetooth Low Energy, you have them with the NFC, which means that you can use them on almost any of the devices out there if they support the WebAuthn API, which means if the browser supports the WebAuthn API. Because the Web Authentication API is a browser API, it's meant for the web. It's implemented by browser vendors, by Chrome, by Firefox, by Safari. And you access that API through JavaScript because that's what we do on the web. So who has one of these? I cannot see you raise your hand, but I'm assuming that some of you have one of these authenticator devices, like a YubiKey or Titan key, and some of you do not. Don't worry. I'm going to show you what this does, how it works, and why it's so cool. So in this example, we have a login field, but there's no password field anymore. There's only a username because I have to tell the website I want to log into, hey, it's me, it's Sam. Can I please log in? So if I click on login, by the way, I have one of those YubiKeys attached to my laptop, which I will use in this demo and the future demos in this talk as well. So when I click on login, my browser is going to ask me for a PIN code just because my YubiKey is protected with a PIN code, and it then asks me to touch it. And because I'm on localhost, I have to allow it every time. But basically, the browser just asks me, hey, can you please touch your YubiKey attached to your computer because I want to do some stuff with it. And what it did was it sent some data to it. The YubiKey signed it, and it sent me back some information. And in this example, we see that we use the private key with ID, this one. It's the ID of your private key. The private key stays securely on the YubiKey on the authenticator device, but we just authenticate it with a YubiKey instead of using a password. So I already asked you who has one of these. Some of you might have one, or a few, some don't. But if I ask who has a modern device, which is a device that's less than 5 years or 10 years old, I think most of you will have a laptop or a phone that's quite recent. And then I'm happy to say that most of these devices have a special chip built into the chipset that does exactly the same thing. It just generates public and key pairs and stores those private keys securely and knows how to use those private keys to sign data, for example. So if you have a modern device, like my laptop is a modern MacBook Pro with Touch ID, you might be able to use that special chip instead of the external YubiKey or the Google Titan key or authenticator device. So again, we have the login screen with only my username. I tell the website, can I please log in? When I click on login, I have to switch to Chrome because my Brave browser has a little bug on it. But when I click login, my Chrome is going to ask me, hey, can you please touch your Touch ID? And when I do so, I have to allow it again because I'm a local host, but we get the exact same result. But instead of using an external USB YubiKey, I used my Touch ID built into my MacBook Pro to do the exact same thing, to create a public and private key pair and to share some data with that private key. So basically, I just logged in with my Touch ID, which is pretty cool. No need to remember a password. My fingerprint is on my hand all the time, so just touch my Touch ID and I'm logged in. It's pretty cool. I'm really happy, really excited about this, but how does this actually work? Because it seems a bit like magic that you can just log in with your Touch ID or with a YubiKey on a website. It sure sounds like it should be very complicated and it should be a lot of work to do that. But it's not that complicated at all. The first thing you need to do is create new credentials. Like with any website you want to register for, you used to register a password. Now we're going to register an authenticator device. You can register multiple, but you have to start with one anyway. So you register your YubiKey or your Touch ID or something, one of those authenticator devices. So the user types in their username while registering on your website, and the browser then relays that username to your backend. And the backend, your authorization server, usually is going to generate a challenge. And a challenge is basically an array buffer with some random or randomish data. Your authorization server is going to generate a challenge and send this to the browser, which will relay that challenge to your authenticator device, which will often ask for user interaction. Like my YubiKey asks me every time to touch it, just so it knows that I am actually here, that I actually want to do this action. So after this user interaction, the YubiKey or the authenticator device is going to create a new private key and public key pair and use that private key to sign that challenge. How signing of challenges works, I'm not going to go deeper into that, but basically it uses this private key to do some mathematical operation with that challenge and then send that signed challenge together with some public key information, which belongs to the private key, and the ID of the private key to the browser, which will then relay that to your backend, and you can safely store that public key information and that ID of your private key, because the private key stays secure on your authenticator device. The only thing that gets sent back from the authenticator device is public data, public key data, and the ID of the private key. So only an identifier, not the ID, the private key itself. So once you've registered, the next time you go to that website, you want to log in using that authenticator device, using that YubiKey, using that Touch ID in your MacBook. So you're going to type in your username again. You could say, hey, it's me, Sam. I want to log in again. I've already registered before, so I should be good to go. So you type in your username, you send it to the backend, and the backend is going to check in the database like, hey, do I have some data for this Sam person? And turns out I have some public key information, and I have a raw ID of the private key. I know my slides say public key, but that's the raw ID of the private key. So it's going to send this to the browser, which will then relay that to your authenticator device, and that authenticator device will be like, do I have a private key that has this ID? I do. Okay, I'm going to use this private key, sign it, ask for some user interaction because I want to make sure the user is actually doing this, and then sign the challenge that you just sent me with that private key of which I had you had the ID stored in your database, and send it all back to your backend, so you can use the public key information to be sure that the right private key has actually signed the challenge. So to recap, because it's quite a few steps, you start by registering an authenticator device. So you request a challenge, an array buffer with some randomish data. You sign that challenge with a private key that's been generated on the authenticator device. And then you send back the signed challenge together with the raw ID of the private key and some public key information, which you can store in your backend together with your username. So instead of saving a password, you save the public key information and the raw ID of the private key on your authenticator device. And the next time the user comes back and wants to authenticate, you request a challenge again, that array buffer with random data. And you also check in your database, do I have a raw ID? Do I have an ID of a private key stored for this user? If so, you send this to the authenticator device so that the authenticator device knows which private key to use, and it uses the correct private key to sign that challenge, and you send it all back to your backend so you can compare the public key information together with the signed challenge, so you know that has been signed by the same private key that you registered previously, because that public key information is linked to the private key. So that's the way it works in a very abstract way. So let's look at some code. George also mentioned, I believe that Touch ID and fingerprints have a legal issue. Law enforcement can compel you to swipe your finger on your phone, laptop, but they can't compel you to reveal your password. Yep, that's a very good remark. Some law enforcement agencies do sometimes ask you this. So if you're concerned about this, don't use Touch ID. Use one of those external authenticated devices, which the law enforcement agencies probably don't know you have, and you're a bit more secure than using the Touch ID. If you're not concerned with this and you just like the ease of use, like just using Touch ID or your face with Windows Hello, for example, then you're free to use that instead of an external YubiKey. But let's look at some code now, and we're going to look at the registering of the credentials first, as that's the first step you need to do. So you're going to create a new set of credentials, and for that we just use navigator.credentials.create. And this is one of two methods by the Web Authentication API. They both live on their navigator because they're implemented by the browser. And you can access them by JavaScript. So you call navigator.credentials.create, let's create a credential, and that accepts a bit of configuration, an object with some parameters that you can tweak and tune to your own liking, and they're all related to the public key information. The first one is a challenge again. It's an array buffer with the randomish data. So you're going to pass along that challenge that's been generated on the backend. The second part is some information about the relaying party. And this is your backend. This is your authorization server. This is the piece of software that's going to handle the authentication. In this case, the idea is my website. The name is myself. But this relaying party information is usually some information about your authorization server. Also, some information about the user can be passed along with this, the ID, the name, the display name. You should be aware that the ID should be anonymous, so it cannot be linked to some actual user data by somebody external. But you can pass along an ID if you want to. And then you can tell the Web Authentication API which kind of algorithms you know how to use. In this case, I'm telling them that I know how to use algorithm -7. If you go to this website, you can see a whole list of algorithms. And if you look at -7, you can see that it's ES256. So -7 is a bit easier to type than ES256, but it's a whole list of algorithms and their corresponding value, number value. So you can pass along a bunch of algorithms that your backend knows how to use. And send them to the authenticator, then it will choose the most convenient algorithm for you out of this list of algorithms that you know how to work with. You can also set a timeout, which means that this is 15 seconds, 15,000 milliseconds, so 15 seconds that the user has to complete the action of touching the Touch ID, touching the YubiKey to complete everything that's needed to authenticate or register a credential. Register a credential in this case because we're creating a new credential. And you can also exclude certain credentials if you want to. And then some information about the authenticator itself. You can specify or filter certain types of authenticators, and authenticators are those external hardware or the internal Touch ID, for example. So if you specify platform, it means it will only allow internal ones like Touch ID, like Windows Hello, the built-in chips into your devices. If you set this to cross-platform, it will only allow external ones like a YubiKey or a Google Titan key. You can also specify if you would like to only allow authenticated devices that have user verification built in. And you can also require resident keys, which we'll talk about in a minute. And lastly, your attestation basically means if the data returned from the authenticated device should be extremely anonymous or almost anonymous. That's what attestation means. It's usually set to direct. So that's all you need to do to register a new credential. You do navigator.credentials.create. You pass along all the configuration you want to kind of set it up the way you like it. And when the user completes all of the actions that follow on this method being called in the front end, you are registered. So the next time you want to use those created credentials, you're going to use navigator.credentials.get instead of navigator.credentials.create. You're using navigator.credentials.get. And again, it accepts some configuration. Again, a challenge, the array buffer. Then a list of allowed credentials. And these are the credentials that you've saved in your backend. So you might put them in this array, and the ID would be the ID of the private key on your authenticator device. And you can specify the way it should be transported, USB, NFC, Bluetooth, or any is fine in this case. And then you can also specify if the user verification should be, if the authenticator should ask for user verification or not. So it's a bit less configuration because the most of it happens when you create credentials. But once you've created the credential and you want to authenticate the user, the most important part is that you pass along the ID of the saved private key ID in this allowed credentials array. So the last thing I want to talk about is resident credentials, because in our previous examples, we still had to type our username, which I think we could get rid of as well. So if we send our required resident key to true in the authenticator selection when registering and when authenticating, we can save some credentials on the authenticator device itself. Instead of only saving the private and public key, we might be able to save also things like the username, some more data than just those keys itself. So if we look at a little example, this website is called webauthent.me, and it basically shows you a little tutorial where you can see what happens, the back and forth between the relaying party, the browser, and the authenticator. If you want to try this out, be sure to go to webauthent.me. But it also contains a bit of information and a debugger. And this debugger basically lets you play around with all of the config you can pass along to those methods, but in a convenient way in the front end. So if I change my username to some Bellen, and my display name is usually Sambigo, and if I click on require resident key, which means that we're going to save my credentials on my attached YubiKey, and I click on register, I have to enter my PIN code because my YubiKey is protected with a PIN code. I have to touch it, but after I touch my YubiKey, I get back some data. And this is the data you get back from the create method, the navigator.credentials.create method. But basically, I just registered myself with my username, Sambigo, and a new private and public key pair on my authenticator device, which means the next time I want to authenticate, instead of passing along the ID of my private key, I'm just going to say, hey, authenticator device, just figure it out. Let's see if you have some credentials stored for my website, which is the current website I'm on. And if so, let me use those credentials instead of me telling you which credentials to use. So when you click on authenticate, it's going to ask me to enter my PIN and to touch my Touch ID. But we can see that I get a list of credentials that have been saved on my YubiKey, including the one I just registered, which was my Bellen or Sambigo name. And that was when my timeout ran out, just 15 seconds. But if I try this again, touch it, and click on the one I just registered, I just authenticate it. I get back some data. So I authenticate it with the resident credentials that have been saved on my authenticated device. No need to enter a username anymore. Just ask the authenticator, hey, do you have some data stored for this website? If so, can the user please log in with those? It's good to note that these credentials are on a website, on a host, on a domain name specific level. So if I save some credentials for webauthent.me, they will not be available for any other website than webauthent.me. They will not be able to for Google, not be available for any of the other websites, just the website you registered it for. So you have to register credentials for every website you want to use this API with. Like I mentioned before, the website webauthent.me/debugger is where you can play around with all of those variables and see what happens if you change a few of them. This is a little example of the Trezor, which basically shows you some more of these saved credentials with a touch screen. It's fancy. You don't need this, but if you have a Trezor, be aware that it can also do this web authentication API thingy. Some issues still to be solved with this API because it's fairly new. User credential management. You can create credentials, but it's not so easy to manage the created credentials. Chrome does have the managed sign-in data, but it doesn't seem to work with all of the authenticator devices out there yet. And if you have a YubiKey, you have the Yubico app, which lets you reset your PIN or reset your whole YubiKey, but it does not allow you to delete or change certain credentials. It's either remove all of it or just leave it as it is. So the management of created credentials is still something that needs to be worked out, that needs to be better. And cross-device credentials, since these credentials are saved on that special chip in your MacBook or on that YubiKey or on that Titan key, they're not always, you cannot transfer them to another device. So if I use my Touch ID on my MacBook, I will have to register my phone as well with a different key or with an external one. Because you cannot use these created credentials across devices. They're securely in place on those authenticated devices or chips. And if this means if you lose your authenticated device or get stolen or broken, you need another way to recover your account. And this can be a recovery code like you can have with Google or GitHub or some other websites. This can be a password even, but you always need a second way of logging in case your authenticated device gets lost, stolen, or broken. So WebAuthn might replace passwords. I think they will in the future. I hope they will, but they do not replace token-based authentication or authorization, things like OAuth or OpenID Connect. They do not replace identity providers like Auth0. They only replace the passwords themselves. That's the only part of the authentication flow that they replace. No need to type a password anymore. Just use one of those authenticated devices to authenticate. And it's a W3C recommendation, which means it's the final spec. The spec has been gone through all of the stages of W3C. And it works in all modern browsers. It works in Chrome, Firefox, and Edge, and it even works in the latest Safari on macOS and on iOS. And it also works on Firefox, on Chrome, on Android as well. So you should be able to use this on all modern devices. This is how it works on iOS. So where can you use this already? Google allows you to use it for a second factor. GitHub allows you. A lot of the bigger websites have support for it, often these days as a second factor, just because we're not used to using this as a first factor. But I don't see any reason why we should not be able to use this in the future as the first factor to replace passwords altogether. In fact, Google and GitHub wrote some very good blog posts about their integration with the Web Authentication API. If you're interested in them, I will link these slides later so you can find the links to those blog posts and read them. WebAuthn.me, it's a website I showed you earlier. As a full disclosure, it's built by me, by Auth0. We don't do anything fishy with the data you enter in here. It's all done on the front end. There's no backend requests being done. So you're completely safe to play around with the Web Authentication API on this website. And it holds a lot of information. So let's summarize. Boo passwords. Passwords, I don't like them. One-time passwords are cool, but WebAuthn is even cooler. Yeah, WebAuthn.me. The spec is quite readable for a W3C spec. And we have a few nice blog posts on our blog about the Web Authentication API and about resident credentials and some more information about all of the configuration variables that you can pass along to the create and get methods. These slides are at 1990.somebigger.tech. Thank you.